All right, so we are going to write polynomials in factored form, standard form, and then we're going to talk about how to find zeros and also some little special cases with what we call a multiplicity. Okay, all we're going to do in the front, just have a little example. So this is a factored form of a polynomial, x minus 5 times x minus 2, those are the two factors, and if we were to sit there and FOIL that out, that would result in this x squared minus 7x plus 10. That's what we call the standard form. So this is factored form here. And then I guess I should have typed this here. This is standard form. So standard form's all multiplied out, and factored form is the set of factors being multiplied together. Okay, now we got to be able to go between the two different formats, and that's what we're going to talk about today. So you guys, I know, have FOILed before, but this is kind of like FOIL on steroids. So I have 3 different factors. So this is going to be a third degree polynomial. Like if I multiply this all out, and I'll do this here in a second, but the highest power, I'd have x here times x here times x here, because we're going to multiply everything together. So the highest power there would be x to the third. So what I would recommend, just do 2 at a time. I'm just going to do these 2 together first. Just a FOIL like you're normally used to. Or you could draw yourself a box if you prefer. So I'm going to go through here, just do FOIL. So I think of it as a double distributive property. X times both of those things. So x squared, x times 3 is 3x. And then negative 1 times both of those. So we're going to get minus x minus 3. Combine your like terms. Now 3x minus x will leave us with 2x's minus 3. Okay, now you still need to multiply by the third factor they gave you in the original problem. Now, totally up to you. What I usually do is I put the factor, like right here, with the smaller number of terms first while I'm doing this. So I'm going to kind of bring that right here because we haven't multiplied by that yet. And this is really just like the FOIL. It's just going to be 3 times. So you're going to multiply x by all 3 of those things, and then you're going to multiply 4 by all 3 of those things. If you do prefer the box method, you can also draw yourself a box. You're just going to make it a 2 by 3. So if you like that little bit more of a visual, I would just put the x in the 4, and then you got your x squared, your 2x, and your minus 3. So if you like that better, that's totally fine. I'm just going to write this to the side over here. X times x squared gives you x to the third. X times 2x, 2x squared, and then x times negative 3 is negative 3x. Okay, now here's how I do these. So that was me multiplying everything by x. Now I'm going to multiply everything by 4, and I'm just going to line up the like terms to make it easier for me to combine at the end. So if I do 4 times x squared, that gives me 4x squared, so I just line it up with the other x squared term. 4 times 2x, going to give you 8x, so I line that up with the other term with the x. And then 4 times negative 3 be negative 12, so there's nothing to combine that with. So I only have 1x cubed. Add these together, you have 6x squared. Negative 3 plus 8 is 5x's, and then there's nothing to combine the 12 with. So this is standard form of that polynomial. Okay, now I'm not going to take a ton of time to go through exactly the same problem. I do want to make a point though, in case you run into anything like this. If you see something that is squared, like x minus 3 is squared here, please do not forget you cannot distribute that exponent because you will completely miss out on the middle term. So if this is squared and you're being asked to put it in standard form, first thing I would recommend is write that factor however many times your exponent is. So this is squared, so I wrote it twice, and then go through the process we just did in that previous question. Again, you could do a FOIL, you could do a box, whatever your preference is. So move on to example 2 here. Okay, now this is going the other direction. I have standard form and we're going to put it in factored form. And this says completely. So I'm going to go through what I mean by that. Okay, first thing for any of these problems, what you should look at is, do the numbers have anything in common? And then also for each of the terms, do they have any variables in common? So I would say to you, all of these numbers are divisible by 3, and I have at least an x in each term. So I'm going to factor that out in front by dividing that. Everybody's divisible by 3x. Okay, 1x comes out, so x squared is left. 18 divided by 3 is 6, and I'm going to take, this is x squared over x, so 1x would be left. And then the last term here, 24 divided by 3 is 8, and the x's would cancel out. Okay, now it's going to totally depend on the question, but you got to ask yourself, can you factor this further? So I need two numbers, not worrying about this. Multiply to give me 8 and add to give me -6. If you sit there and think about that combination, this is going to be x minus 4 times x minus 2. All right, so -4 times -2 gives you +8. If you FOIL that back out, that'll give you the -6. So the rules for this is a times c, the add to the b value. So this would be 1 times 8, so multiply to get 8. The b value is the term in the middle, and the coefficient of x is going to be the actual b value. So for this question, that was -6. And you're going to see in the next couple of examples why we would really like to have our equations, or our polynomials, sorry, in this format. Okay, same thing here. Both of these numbers are divisible by 2, and I have at least x squared in both. So I've got 2x squared. I can take that out in front. 2 divided by 2 would just cancel out, and I'd have x squared left here. 50 divided by 2 is 25, and then those x squareds cancel. Now this is another thing I wanted to remind you about. So this is a difference of squares. So kind of like this, I need to multiply to get -25 and add to get 0 because I don't have a middle term. Should just be the square root of each of those. So I'm going to do x plus 5, x minus 5. 5 times -5 gives you the -25. 5 plus a -5 gets rid of that middle term, so that's going to be 0. Okay, and then the last one, this one's probably the trickiest. It requires that Berry method, but before I start that out, all these numbers are even, and so they're at least divisible by 2, and I think that's going to be it. And they each have at least an x squared, so we're going to take out a greatest common factor. So pull that out in front. Now, 6 divided by 2 is 3, so we'll have 3x squareds left. 40 divided by 2 is 20 with an x left. And 14 divided by 2, this is 7. Okay, now I'm just focusing on the parentheses, this quadratic. Multiply AC, add to B. So for this problem, 3 times -7 is -21. Add to get the value in the middle, which is going to give you 20. Okay, so I got to keep this 2x squared out in front. Now, if you guys remember the Berry method, this only happens if there's a number in front of the squared term, which there's a 3 here. This is not the correct answer, but you're going to start out and just drop that first term with no squared in both of the first parentheses, the factors there. Okay, multiply to get -21, but add to get 20. I'm going to say that's going to be -20 times 1. No, that's not going to work. What am I thinking? Okay, multiply to get -21. So let's do 21 times -1. And then 21 times -1 will multiply to give me -21, but that will add up to 20. So it doesn't matter. In one of these, put a +21, and in the other, put a -1. Now, remember, this is not the factored form, because if I multiplied this back out, 3x times 3x does not give me back 3x squared. what you're looking for here is within your factor, inside your parentheses, do the numbers have anything in common? And if they do, that's not the real factor. So 3 and 21 are both divisible by 3, so that's not the real factor. And all you need to do, it just disappears out, a little trick to this. The real factor is going to be x plus 7, 3x minus 1, and then let me just do a quick spot check. X times 3x would give you back the 3x squared, and 7 times negative 1 should be the negative 7. If you want to completely FOIL that back out to check that it matches up with this, you can, but we should be in good shape. So this is the factored form. Started with standard, ended up in factored. And now we're going to get into the whole reason that we're doing this. So we're going to start solving polynomial equations. And so what we call a zero is the value of x that makes the equation true. When the equation is set equal to 0. And the reason it's called a zero is because one side of your equation is 0. The other side would have some algebra on it, and we would be trying to find the values that would make the equation equal to 0 if we plugged them in. So we're just going to do a little practice here. I'm going to give you what I call a zero. So this is going to kind of look like what we were just doing, except these are going to be equations and not just expressions. So I'm going to say 0 equals. Okay, so if 4 is my answer, then x minus 4 would be a factor. If negative 3 is an answer, or a 0, or a root, I usually call them zeros, then x plus 3 would be the factor. And if you have 2, x minus 2. So the way this works, if I put in 4, here this term would be 0 times something, doesn't matter. 0 times 2 other things is going to give you 0. Here, if I plug in negative 3, this would be, well, if I plugged it in, this would be negative 7, this would be 0, and this would be negative 5. But if you multiplied it out, the 0 would wipe everything else out. And then here again, if I plug in 2, when I multiply this all out, if I plug in 2 for each of the x's, this one ends up being 0, so when I multiply that, I get 0. Okay, so this would be the factored form of the equation, and I would be looking for the equal sign and the 0. So it's a little bit of an extra step from what we were just doing. Okay, let me show you how to work these. If 0 is one of your answers, you can literally just represent that. Let me start off by writing an equation. 0 equals, just put an x. That's it, because if I plug in 0 right there, it's going to wipe out whatever I multiply it by. Now I've got a 3, so it'd be x minus 3. And the last one is probably the trickiest. So if you end up with a fraction, it's going to be, let me just point your attention here. If I was back up here, and I wanted that to be equal to 0, just as a little example, I would add 1 to both sides if I wanted that to be 0. So I get 3x is 1, and then we would divide by 3. So if you have a fraction as one of your zeros, like I do here, it's going to work kind of like that. Now, whatever is on the bottom, you're going to end up dividing by that. So this is going to be multiplied by x, and then on the top is add or subtract depending on the question. Now, if the 0 is positive, then in the factor it will be a minus. So you guys can see that as an example. If your 0 is negative, in the factor it'll be positive, so it'll be the opposite. So this is a positive number. So 2/5 would be 5x minus 2 as a factor. You would add 2 if you set that equal to 0 and divide by 5. So you can work backwards like that. Okay, now when you're talking about zeros, there's kind of what I would call a special case, which is called a multiplicity, and or a multiple 0. So all this is a 0 that happens more than once. So like if we'll get into this in a second, but if we have factors that are the same and we have a couple of them, maybe we have 3, maybe we have 4, that is a possibility for these. And what they call the multiplicity is just the number of times that that 0 occurs. So I'm going to write that number of times a 0 occurs. And it's always equal to the exponent. And I'm going to explain that with the next example. So this says I have 2 zeros, -5 and 3 multiplicity 2. So here's all this means. X plus 5 would be the factor. And then 3 multiplicity 2 would be x minus 3 for the factor, and the multiplicity just means that would be squared. So this would be, if we multiplied this out, a cubic function. This one says 0, so I'm just going to put x with multiplicity 4. So I'm going to put that to the 4th power and 7. So that would just be an x minus 7 if we were writing that. All right, so let's just dive in here. This says find the zeros, and we're going to state the multiplicities if they have any. So this would be 0. If I plugged in 0 for x, the multiplicity would be 2. It just matches the exponent. Okay, all I'm going to do here is just really quickly, actually I should have done this to the side. This is a difference of squares. You can factor x squared minus 64. It's an x minus 8 and an x plus 8. So let me show you this very quickly, but I'll also show you an alternative. So if I hadn't done that, what you would want to do is set that equal to 0, because that's where you get your 0, is to set your factor equal to 0. If I solve this little equation, I would add 64 to both sides, and we'd take the square root, and I would get 8 or -8. There's no multiplicity involved in that, and that's why I was using that as an example. The squared is not on the parentheses, it's just on the x. So this is going to have 2 answers. The other way is what I just did here, is to write that in factored form. Okay, so, and you can get the same answers. So again, this is 0 multiplicity 2. This would be 8. This would be -8, and this would be -5. And when we're doing there, we don't have multiplicities on any of those others because they just occur one time. So you don't write multiplicity 1, you just go ahead and write the 0. So this has 4 different answers. All right, now these guys are already in factored form. So again, it's whatever would make that 0. So if you want to set yourself up a little equation, here I would add 2 and divide by 3. No multiplicity on that because there's no exponent. Right here, if that was equal to 0, all we would do is subtract 2. Now, this has an exponent, so you go ahead and say multiplicity 4. Okay, now I just kind of am going to think through this. If I set this equal to 0, I would subtract 5, divide by 2. No multiplicity to write down because there's no exponent. Here, I'd plug in -6. This does have an exponent, so I just go ahead and write multiplicity 3. And then this last one, this would be 8 with a multiplicity of 2. Okay, and then this last set of questions is going to tie in what we were doing on the front. So it's very easy to find the zeros if it's in factored form. That's what we were just doing here and here. If it's in standard form, you want to put it in factored form so you can see the answers. These are not equations you can solve as they're written. You can't combine like terms. There's nothing like that to do. So the easiest way to solve this is by factoring. So you want to completely factor. So let's go through that. First thing, you notice all these have at least an x squared in them. So I'm going to divide each term by x squared. And left over, this would be x squared minus x minus 12. And here, I'm going to factor the quadratic. So I'm going to multiply to get -12, add to get -1. So the factors there, we're going to do an x minus 4 and an x plus 3. -4 times 3 is -12. -4 plus 3 is -1. Now, once we're in factored form, so much easier to solve. So this is 0. Multiplicity would be 2. This is just a plain +4. If we plugged in 4, that would give us 0. This is just a -3, no multiplicity because we don't have any exponents. So this question has 3 different answers. One of them has a multiplicity. Same thing here. I'm going to divide both of these by x squared. They both have at least x squared. Left over, we'd have x squared minus 49. This is a difference of squares. Multiply to get 49, add to get 0. Now, again, I have a 0 as one of my answers, and it has a multiplicity of 2 because it's squared. If I plugged in +7, that would make that factor 0. If I plugged in -7, that would make that factor 0. And we're going to see here if we can just do one more. Now, each of these numbers is even, so they're at least divisible by 2, and I have at least an x. So I'm going to take a 2x out in front. Whoops, keep that equal to 0. Left over, we'd have x squared minus 6x plus 9. Okay, so got to keep the 2x here. So multiply to get 9, add to get -6 is going to be x minus 3, x minus 3, or, since those are exactly the same, x minus 3 squared. Now, just be real careful here. What would I plug in to 2x to make that 0? And some people will accidentally tell me 2, but it's not 2. If you want that to be 0, think about setting that 2x equal to 0. If I divide, x is 0 there. There's no multiplicity. It's just if I plugged in 0, 2 times 0 would wipe the whole thing out. Here we would plug in +3. That does have a multiplicity because there's an exponent on those parentheses.